Welcome to Galaxy Guru, your ultimate guide to the galaxies that shape our universe. Thank you for joining me. My name is Gino, and today we're diving into a cosmic mystery that has astronomers scratching their heads. A galaxy with no stars. That's right. We're stepping into the shadows of the cosmos to explore a discovery that defies imagination. Picture this. A starless galaxy. No shimmering lights. Just a vast, silent sea of gas and dark matter drifting through space. This is J0613+52, a cosmic oddity stumbled upon by astronomers in 2023. It's a find that rewrites the rules of how we think galaxies come to be. Let's set the scene. How was it found? By pure chance. Astronomers were scanning the sky with the Green Bank telescope, a massive radio dish tuned to catch the faintest signals from the universe. They weren't looking for J0613+52. No one was. They were mapping hydrogen clouds, tracing the building blocks of galaxies. Then, something unexpected appeared. A signal too strong, too distinct to ignore. It was a galaxy, but not like any they'd seen before. Now, let's pause for a moment. Imagine the implications. Galaxies are supposed to form stars. That's their story. Gas collapses under gravity. It heats up, ignites. And over billions of years, it becomes a dazzling spiral or a glowing ellipse. But J0613+52, it never got that far. It's frozen in time. A relic from the early universe, a snapshot of what might have been before stars were born. What makes it so strange? For one, its isolation. Most galaxies have neighbors. They collide, they merge, they shape each other over eons. But J0613+52 stands alone. Now it's time we're asking a big question. What is a galaxy? Buckle up, because understanding this will make J0613+52 even more mind-blowing. Picture the universe as a giant sprawling ocean. It's dark, vast, and seemingly endless. Now, imagine little islands scattered across this ocean. These islands aren't made of sand or trees. They're made of stars, gas, dust, and something invisible called dark matter. These are galaxies. Each one is a massive neighborhood in space, held together by gravity, buzzing with activity. Some have billions of stars. Others have trillions. They're where the action happens, where stars are born, shine, and eventually fade away. Galaxies are like the cities of the cosmos. They're the places where the universe organizes itself. But just like cities on Earth, no two galaxies are exactly alike. They come in different shapes, sizes, and personalities. Let's meet the three main types: spiral, elliptical, and irregular. First up, spiral galaxies. These are the rock stars of the galaxy world. They look like cosmic pinwheels with bright arms spiraling out from a glowing center. Our own Milky Way? That's a spiral galaxy. It's a flat, spinning disk with stars, gas, and dust swirling together. Those arms you see in pictures, they're where new stars are born, lighting up the galaxy with their youthful glow. Spiral galaxies are organized, dynamic, and downright beautiful. Next, we have elliptical galaxies. These are a little less flashy. Think of them as cosmic footballs, smooth, oval, and simple. They don't have those dramatic spiral arms. Instead, they're packed with older stars, ones that have burned through their gas long ago. Elliptical galaxies are like the quiet, retired neighborhoods of space. Star formation has mostly stopped, and they just sit there, glowing softly with the light of ancient suns. And then, there are irregular galaxies. These are the rebels. They don't follow the rules of spirals or ellipticals. Their shapes, chaotic, unpredictable. They might look like a splash of paint or a jumbled mess. Irregular galaxies often form when bigger galaxies crash into each other, shaking things up. They're the abstract art of the universe, wild, messy, and full of surprises. So, what's inside a galaxy? Let's break it down to the building blocks. First, stars. These are the headliners. Stars light up the galaxy, from tiny, cool red dwarfs to massive, blazing blue giants. They're the engines that drive everything, creating light, heat, and even the elements that make up you and me. Next, gas. This is the raw material, mostly hydrogen and helium. It floats between the stars in huge clouds. When it gets dense enough, it collapses under gravity and bam, a new star is born. Gas is the fuel that keeps the galaxy's star factory running. Then there's dust. Not the stuff under your couch, but tiny grains of carbon, silicon, or other elements. Dust might block starlight, creating dark patches, but it's also a key player. It helps form molecules that can eventually become planets. Dust is the unsung hero of the galaxy game. And finally, dark matter. This is the weird one. We can't see it, we can't touch it, but we know it's there because of how it pulls on everything else. Dark matter is like the invisible scaffolding that holds the galaxy together. Without it, the stars and gas would just drift apart. It's the silent partner in this cosmic dance. That's a galaxy in a nutshell. Stars, gas, dust, and dark matter, all working together to create these incredible systems we see in the night sky. Normally, when we think of a galaxy, we picture those shining stars, billions of them, twinkling away. But here's where things get strange. What if a galaxy didn't have any stars at all? What if it was just gas and dark matter, sitting out there in the void? That's J0613+52, a galaxy with no stars. It's like a city with no lights, no people, just an empty framework. How does that even work? How can something be a galaxy without the one thing we assume defines it? That's the puzzle we're here to unravel. Now we'll dive into the wild story of how J0613+52 was found. It's a tale of chance, cutting-edge tech, and a galaxy that breaks all the rules. We'll explore what it's made of, why it's so different, and what it tells us about the universe. So, stick around. So far we unpacked what makes a galaxy tick, those sprawling cities of stars lighting up the universe. Now it's time we're diving into a discovery that turns that idea upside down. This is the story of J0613+52, a galaxy like no other, stumbled upon by accident. So, settle in, because this tale is packed with surprises, cutting-edge science, and a little cosmic magic. Let's dive in. Imagine it's 2023. A team of astronomers is huddled around their computers, working with one of the most impressive tools in the stargazing toolkit, the Green Bank Telescope in West Virginia. This isn't your backyard telescope peering at twinkling stars. No, the Green Bank Telescope, or GBT, is a giant radio dish, 100 meters across, built to eavesdrop on the universe's hidden whispers. It catches radio waves, signals our eyes can't see, from gas clouds, pulsars, and other cosmic oddities. On this particular day, the team is mapping hydrogen gas, the raw material of galaxies, trying to piece together the universe's unseen scaffolding. But here's where the story takes a twist. Someone, maybe tired, maybe distracted, types in the wrong coordinates. A small slip, a tiny error in the numbers. The telescope swings off target, pointing at what looks like a blank patch of sky, 270 million light years away. They could have corrected it and moved on. Instead, They let the data roll in, and what comes back stops them in their tracks. That empty spot, it's not empty at all. It's hiding something massive, something bizarre. What they found was a colossal cloud of hydrogen gas, enough to fuel billions of stars spinning out there in the void. But when they turned optical telescopes, the kind that chase starlight, to the same spot, they saw nothing. No stars, no shimmering lights, just darkness. This wasn't a typical galaxy glowing with stellar fireworks. It was a ghost, invisible to the naked eye but shouting its presence through radio waves. They named it J0613+52, and it's been shaking up astronomy ever since. Now, let's paint a picture. Most galaxies are like bustling metropolises. Stars are the streetlights, gas is the fuel, and gravity keeps it all humming. J0613+52, it's more like a quiet, foggy swamp. It's got the gas, tons of it, and dark matter holding it together. But the lights never turned on. No stars. Just a spinning mass of potential. 270 million light years from Earth, defying everything we thought we knew about how galaxies work. The discovery was pure serendipity. A happy accident that joins a long line of scientific flukes. Think about it. Penicillin came from forgotten mold, the microwave from a melted candy bar. In astronomy too, chance has a way of stealing the show. Pulsars were a surprise, the cosmic microwave background a fluke. And now, J0613+52, a typo in coordinates, unveils a galaxy that shouldn't exist. It's a reminder that sometimes the universe rewards us when we stumble. So, how do you find something that doesn't shine? That's where the Green Bank telescope shines, pun intended. Radio telescopes like the GBT don't care about visible light. They are tuned to pick up radio signals, like the faint hum of hydrogen gas. Every atom of neutral hydrogen emits a unique radio wave, a cosmic calling card. For J0613+52, the GBT caught that signal loud and clear. A massive stash of gas swirling in the dark with no stars to light the way. It's like finding a treasure chest buried in a pitch-black cave. You can't see it, but you can hear it calling. When the team realized what they'd found, they couldn't believe it. Galaxies are supposed to be star-making machines. Gas collapses under gravity, heats up, and bam, stars are born. But J0613+52 is a cosmic tease. It's got all the ingredients: gas, mass, spin. But the oven never fired up. Why? That's the million-dollar question. Maybe it's too spread out for gravity to work its magic. Maybe it's a relic from the universe's early days, caught before the stars could spark. Whatever it is, it's a rule breaker. And astronomers love a good mystery. This discovery was so big, it took the spotlight at the 243rd American Astronomical Society meeting in January 2024. Karen O'Neill and her team stood before a packed room, unveiling J0613+52 to gasps and whispers. Was this a new type of galaxy? A missing link in cosmic evolution? The buzz was electric, and the questions piled up faster than the answers. Here's the thing. J0613+52 isn't just a weird galaxy. It's a wake-up call. It tells us the universe is still hiding secrets, waiting for us to trip over them. It's proof that science isn't always about precision. Sometimes it's about embracing the unexpected. And for us here at Galaxy Guru, it's a story we can't get enough of. Next, we'll zoom in on J0613+52, its size, its makeup, and why it's such an oddball. By the way, Thanks for joining us on Galaxy Guru. If this starless wonder has you hooked, smash that subscribe button. Thank you. Anyway, back to J0613+52, a galaxy that's turning astronomy on its head. We just uncovered how this starless marvel was spotted by mistake with the Green Bank telescope. Now, we can begin zooming into its core properties. How far away it is, how much gas it holds, its total mass, and why it's missing the one thing we expect from every galaxy: stars. To make it relatable, we'll stack it up against our own Milky Way. Buckle up, space fans. Here we go. First up, where is J0613+52? This galaxy is 270 million light years from Earth. Let's break that down. A light year is the distance light travels in 1 year, about 5.88 trillion miles. So, 270 million light years means the light we're seeing from J0613+52 today started its journey 270 million years ago. Back then, Earth's dinosaurs were still stomping around and humans were nowhere in sight. It's like a window into the ancient universe. But here's the fun twist. In the grand scheme of the cosmos, 270 million light years isn't that far. The observable universe stretches over 93 billion light years across, making J0613+52 a relatively close neighbor. Yet, despite being near enough to study, it stayed hidden until a happy accident revealed it. Next, what's J0613+52 made of? Most galaxies dazzle us with stars, but this one's all about gas, specifically hydrogen, the raw material for star formation. J0613+52 packs between 1 and 2 billion solar masses of gas. A solar mass is just the mass of our sun, so that's 1 to 2 billion suns worth of gas floating around. How does that compare? The Milky Way has about 1 billion solar masses of gas, so J0613+52 matches or even doubles our galaxy's gas supply. But here's where it gets wild. The Milky Way has churned its gas into hundreds of billions of stars, while J0613+52 hasn't made a single one. It's got the ingredients for a stellar bakery, but the oven's been off for millions of years. Gas is only part of the story. Galaxies are massive because of something invisible: dark matter. This mysterious stuff doesn't glow or reflect light. We only detect it through its gravitational pull. In J0613+52, the total mass, gas plus dark matter, is on par with spiral galaxies like the Milky Way, clocking in around 1 trillion solar masses. Let's do the math. The gas is 1 to 2 billion solar masses, barely a drop in the trillion solar mass bucket. That means dark matter makes up the vast majority of J0613+52's heft. It's the unseen glue holding this galaxy together, dwarfing the gas and leaving no room for stars. Picture it as a massive, shadowy framework with just a thin veil of gas draped over it. Now, the headliner, J0613+52 has no stars. None. Not a single twinkling light. Most galaxies, like the Milky Way, with its 100 billion plus stars, shine bright because of these fiery orbs. But J0613+52 is a galactic ghost, invisible to optical telescopes. If it weren't for its gas emitting faint radio waves, caught by the Green Bank telescope, we'd have missed it entirely. This defies everything we know. Stars are a galaxy's heartbeat, yet J0613+52 exists without one. It's stealthy, silent, and utterly unique, a cosmic riddle begging to be solved. Let's put it side by side with the Milky Way, gas, Both have around 1 billion solar masses of gas. Check. Total mass. Both hover near 1 trillion solar masses thanks to dark matter. Check. Stars. Milky Way. Over 100 billion. J0613+52, 0. Big difference. It's like comparing two chefs with the same ingredients. The Milky Way cooked up a stellar feast, while J0613+52 left its pantry untouched. Why? That's the million light-year question scientists are chasing. What's next? So, J0613+52 is a massive, gas-rich, dark matter-heavy galaxy with no stars. How does that even happen? We will have to dig into the theories. Could it be too spread out, too lonely, or something stranger? Stick with Galaxy Guru as we continue to unravel this cosmic mystery. At this point, we are pretty familiar with J0613+52, a galaxy that's breaking all the rules. It's got gas, it's got dark matter, but no stars. None. Now it's time to be diving into the big question. Why hasn't J0613+52 formed any stars? Stars are the lifeblood of galaxies, so what's keeping this one in the dark? Let's unravel the clues, step by step. First, let's set the scene. Imagine a galaxy as a bustling cosmic kitchen. The main ingredient? Gas, mostly hydrogen. Gravity is the chef, kneading that gas until it clumps together. When it gets dense enough, it collapses, heats up, and bam, a star is born. It's a straightforward recipe. Gas plus gravity equals stars. J0613+52 has the gas, 1 to 2 billion solar masses of it, but the kitchen's silent. No stars. So, what's gone wrong? Let's investigate the suspects. Here's the first theory. Maybe the gas is too diffuse. Picture trying to build a sandcastle with dry, loose sand. It just falls apart. In J0613+52, the gas might be stretched too thin across its vast expanse. Without dense pockets, gravity can't get a grip to spark star formation. It's like having all the flour for a loaf of bread, but no bowl to hold it together. But wait. Other galaxies with similar gas amounts do form stars. So, is it really just about density? Let's keep digging. Next up, a lack of heavy elements. What are those? In space terms, heavy elements are anything beyond hydrogen and helium, like carbon, oxygen, or iron. These act like a cooling system. They help gas lose heat, and cooler gas is easier for gravity to mold into stars. Think of it as dough setting faster in a fridge. Here's the kicker. Heavy elements come from stars. When stars die, they explode, scattering these elements into space. But J0613+52? No stars, no explosions, no heavy elements. It might be stuck with pristine, early universe gas. Too warm and fidgety to settle down. Is it missing the coolant it needs to get started? Now, let's talk isolation. Most galaxies have neighbors, cosmic dance partners. When they get close, their gravity stirs up gas, triggering star formation like a beat dropping at a party. But J0613+52 is a wallflower, out there with no one to tango with. Without those gravitational nudges, its gas might just be sitting there, unmoved and unmotivated. It's like a dance floor with no rhythm. Everyone's present, but no one's dancing. What about temperature? If the gas in J0613+52 is too hot, it's a no-go. Hot gas is like a swarm of buzzing flies, too restless for gravity to pin down. Normally, gas cools over time, setting the stage for stars. But if J0613+52's gas is staying warm, maybe from heat trapped since its birth, it could be stuck in a starless limbo. Here's the puzzle. With no nearby heat sources and no heavy elements to trap warmth, why would it stay hot? Temperature might be a piece of this mystery, but it's not the whole picture. Now, here's a mind bender. What if J0613+52 isn't just odd? What if it's ancient? A leftover from the universe's infancy, before stars lit up the sky. Back then, gas and dark matter floated around, waiting for the first sparks. Most galaxies evolved, but maybe J0613+52 didn't. Maybe it's a time capsule, a starless snapshot of a primordial cosmos. If that's true, we're not just studying a galaxy, we're peering into the past. So, what's the answer? So why no stars? Is it the thin gas? The missing elements? The loneliness? The heat? Or some cosmic combo of all these factors? Right now, we don't have the final word. Astronomers are still watching, hoping for a hint, maybe a faint star we've missed, or a clearer look at the gas's properties. But even without all the answers, J0613+52 is rewriting the galaxy playbook. It's proof the universe still has secrets up its sleeve, and we're just along for the ride. Next, we'll tackle dark matter's role in J0613+52. How does this invisible force shape a galaxy with no stars? And what does it tell us about the unseen scaffolding of the universe? It's a fun concept, so let's move right into it. By the way, thanks for joining us on this starless adventure. We are so happy to be a part of your day. Okay, now that we have dug into why this galaxy never lit up with stellar fireworks, we're now going to be shining a spotlight on the invisible force that's keeping it all together. Dark matter. This shadowy stuff is the key to J0613+52's existence, and maybe to the universe itself. Buckle up, because we're diving deep into the unseen. Let's start with the basics. Dark matter is the universe's ultimate hide-and-seek champion. It doesn't glow like stars, it doesn't reflect light, and it doesn't send us friendly radio signals. We can't see it or touch it, but we know it's there because of what it does. Dark matter makes up about 27% of the universe's mass energy, way more than the 5% that's regular stuff, like planets, stars, and you. The other 68%. That's dark energy, but that's a story for another day. Picture dark matter as the invisible scaffolding of the cosmos. It's like the steel frame inside a skyscraper, hidden from view, but without it, the whole structure would collapse. In galaxies, dark matter acts like gravitational glue, holding stars and gas in place. Without it, everything would fly apart like a cosmic explosion gone wrong. And in J0613+52, where there are no stars to anchor things, dark matter steps up as the silent hero keeping this ghostly galaxy intact. So how does dark matter work its magic in J0613+52? In a normal galaxy, dark matter forms a giant halo, a massive invisible cloud that wraps around the stars and gas. It's like a gravitational net, pulling everything toward the center. For J0613+52, that net is still there, but it's catching something unusual: gas. About 1 to 2 billion solar masses of it. Here's the kicker. The total mass of this galaxy is around 1 trillion solar masses, similar to our Milky Way. With only 1 to 2 billion solar masses of gas, that means over 99% of J0613+52's mass is dark matter. This isn't just a galaxy, it's a dark matter empire with a sprinkle of gas on top. But wait, if dark matter is so good at pulling things together, why hasn't it sparked stars in J0613 plus 52. In most galaxies, dark matter's gravity squeezes gas into dense pockets where stars are born. So what's different here? One idea is that the dark matter halo is too spread out. Instead of clumping the gas tightly, it's holding it in a loose, fluffy cloud, like a net, with holes too big to catch the little fish. The gas just floats there, never dense enough to ignite. It's a cosmic Goldilocks problem. Too little dark matter and the gas escapes. Too much and it collapses into stars. In J0613+52, dark matter seems to have found the just right spot to keep things starless. Now, let's get to the weird part. We don't actually know what dark matter is. Scientists first spotted its effects in the 1930s, watching how galaxies moved faster than they should. Since then, we've been chasing shadows. We can measure its pull on stars, on light, on gas, but we can't grab it. Some think dark matter is made of exotic particles like WIMPs, weakly interacting massive particles, or tiny things called axions. Others wonder if it's not particles at all. Maybe it's a tweak in how gravity works. The jury's still out. J0613+52 is like a gift to dark matter hunters. With no stars to muddy the view, we can study how dark matter shapes the gas all by itself. By tracking the gas's motion with radio telescopes, astronomers can map the dark matter halo's size and strength. It's like figuring out a puzzle by studying the edges. Each clue gets us closer to the big picture. Zoom out with me for a moment. Dark matter isn't just a local hero in J0613+52. It's the master builder of the universe. After the Big Bang, dark matter clumped together first, creating gravitational wells that pulled in gas to form galaxies. No dark matter, no galaxies. No galaxies, no stars. No stars, no us. It's the foundation of everything we see. In J0613+52, dark matter built the framework, gathered the gas, and then stopped. It's like setting up a grand stage for a play, only to realize the actors never showed up. The galaxy exists, but the starlight never came. Why? That's the million-dollar question driving scientists crazy and keeping us hooked on this mystery. What's next? J0613+52 is a treasure trove for astronomers. New tools like the Square Kilometer Array, a massive radio telescope project, could map its dark matter halo in stunning detail. If we crack how dark matter behaves in this starless oddity, we might figure out what it's made of. Could it rewrite physics entirely? And here's a mind-bender. Some think J0613+52 might be a relic from the early universe, a snapshot of a time before stars dominated. Its dark matter could hold clues to those ancient days, like a time capsule floating in space. Every observation brings us closer to unlocking its secrets. So, where are we? Dark matter is the invisible giant holding J0613+52 together. A trillion solar mass anchor for a galaxy with no stars. But why no stars? Is the dark matter too diffuse? Is the gas too stubborn? Or is this just a cosmic fluke? For now, the mystery lingers, teasing us from the shadows. At some point, we begin to ask, what does J0613+52 mean for galaxy formation? Are there more starless galaxies out there? And how does this change what we call a galaxy? What does this discovery mean for how we understand the universe? Buckle up. This isn't just about one weird galaxy. It's about rewriting the cosmic story. Let's dive in. First up, let's tackle the basics. When you picture a galaxy, what do you see? Swirling arms of stars, glowing nebulae. Maybe a supermassive black hole at the center, right? That's the classic recipe. Stars, gas, dust, and dark matter, all mixed together by gravity. Stars are the shining stars of the show, the beacons we've used to define and spot galaxies for centuries. But J0613+52? It's missing the main ingredient. No stars, none. So here's the big question. Is it still a galaxy? This isn't just nitpicking. It's a cosmic identity crisis. If a galaxy can exist without stars, maybe we've been too narrow in our thinking. Perhaps galaxies are really just massive clumps of dark matter, and stars are an optional bonus. Or maybe J0613+52 is a new breed entirely. A proto-galaxy, a galactic misfit. Think of it like finding a cake with no sugar. It's still a cake, technically, but it forces you to rethink the recipe. J0613+52 might just be the push we need to redefine what a galaxy can be. How many more are out there? Now, let's stretch our imaginations. J0613+52 was discovered by pure luck. A typo sent the Green Bank telescope looking in the wrong spot. And boom, there it was. A starless galaxy, invisible to the naked eye and our usual telescopes. That got astronomers wondering, if we found one by accident, could there be others? Here's the kicker. Without stars, these galaxies don't glow. They're stealthy, hiding from optical telescopes. We only caught J0613+52 because we listened for its radio whispers. So, what if the universe is teeming with these silent giants and we've just been blind to them? With the right tools, like powerful radio telescopes or next-gen surveys, we might uncover a whole population of starless galaxies. It's like realizing the ocean has a deeper layer we never fished in. Suddenly, the universe feels bigger, stranger, and a lot more mysterious. Let's take a step back, way back, to the beginning of everything. Picture the universe right after the Big Bang. A hot, chaotic mess of gas and dark matter. No stars, no structure. Over billions of years, gravity sculpted that mess into the galaxies we know today. But what if J0613+52 is a leftover from that early chaos? A galaxy that never grew up, stuck in a primordial state. If that's true, it's a treasure trove. Its gas might be pure, untouched by the heavy elements stars forge in their fiery deaths. Studying it could show us what the universe was like before stars ignited, back when it was just raw ingredients waiting to cook. J0613+52 isn't just a galaxy. It's a time capsule, a snapshot of the cosmic dawn. Imagine holding a photo of the universe as a baby. That's the kind of insight this discovery could offer. So, where do we go from here? J0613+52 isn't just a one-off curiosity. It's a spark that could light up astronomy for years to come. Let's break it down. New rules. If starless galaxies are real, we might need to rewrite the cosmic playbook. Our galaxy count could skyrocket once we adjust the definition. The hunt is on. This discovery could kick off a galaxy hunting spree. With tools like the Square Kilometer Array, we might spot more of these elusive objects, filling in gaps we didn't know existed. Dark matter. Detective work. J0613+52 is a clean slate for studying dark matter. No stars means less noise. We can map its dark matter halo with precision and test our wildest theories. Origins unraveled. If it's a relic from the early universe, it could unlock secrets about how galaxies first formed, or why some never did. This little galaxy is a big deal. It's a nudge to keep asking questions, to keep looking beyond the obvious. The universe loves a good plot twist, and J0613+52 is proof we're still in the middle of the story. As we close out this chapter, let's linger on the awe of it all. J0613+52 isn't just a galaxy. It's a challenge, a mystery, and an invitation. It shakes up our assumptions, widens our view, and reminds us how much we have left to learn. The universe isn't done surprising us, and that's what makes it so thrilling. Now let's tie it all together and recap. J0613+52's journey, then peer into the future of cosmic discovery. Stick with Galaxy Guru as we chase the unknown. And by the way, friends, thanks for exploring this starless wonder with us. If J0613+52 has your mind buzzing, consider subscribing for alerts. Enjoy your day. Now, friends, together we've followed the wild ride of J0613+52, a galaxy that's flipped the script on everything we thought we knew. No stars, just a swirling cloud of gas and dark matter. It's like the universe decided to throw us a curveball. Now, let's begin wrapping it up with a recap, yet another jaw-dropping twist about its significance, and a peek at what's next. Ready? Let's blast off one last time. The journey so far, a galactic oddball. First, let's rewind. J0613+52 burst onto the scene in 2023, spotted by accident with the Green Bank telescope after a typo sent astronomers looking in the wrong spot. Talk about a happy mistake. Sitting 270 million light-years away, this galaxy is a massive blob of hydrogen gas with no stars to light it up. Just gas and dark matter, spinning quietly in the cosmic shadows. Through this series, we've unpacked why it's so strange. Maybe its gas is too thin to collapse into stars, or it's missing the heavy elements needed to kickstart star formation. We've talked about its isolation, its possible warmth, and how dark matter might be the glue keeping it together. But J0613+52 isn't just a quirky outlier. It's a window into something much bigger. Here's where things get wild. What if J0613+52 isn't just a weird galaxy? What if it's a primordial galaxy? A time capsule from the dawn of the universe. This angle adds a whole new layer to its story, and it's too cool not to explore. Imagine the universe billions of years ago, fresh out of the Big Bang. It's a chaotic mess of gas and dark matter. No stars, no galaxies, just the raw stuff of creation floating around. Over time, gravity pulls that gas into clumps, sparking the first stars and building the galaxies we know today. But J0613+52? It might have hit the pause button. Unlike most local galaxies, like our Milky Way, which have evolved over eons, recycling gas through generations of stars, J0613+52 could be pristine, untouched by that cosmic churn. Its gas might lack the heavy elements, like carbon or oxygen, that stars forge and scatter when they explode. Think of most galaxies as old cookbooks filled with recipes tweaked by countless chefs. J0613+52 though? It's the original ingredients, straight from the pantry, never cooked. If it's truly primordial, studying it could show us what the early universe looked like before stars lit up the sky. It's like finding a Polaroid of the cosmos as a baby. Blurry, mysterious, and totally one of a kind. This isn't just about one galaxy. It's about peering back to the beginning of everything. That's the kind of depth J0613+52 brings to the table. It's not just odd, it's a bridge to the past. So, what's next for J0613? J0613+52. What do we do with this cosmic treasure? Astronomers are already plotting the next steps, and the future looks packed with possibility. Here's the rundown. Dark matter deep dive. With no stars to distract us, J0613+52 is a goldmine for studying dark matter. Next-gen telescopes, like the Square Kilometre Array, could map its dark matter halo, revealing how this invisible stuff shapes or stalls galaxy formation. The hunt for cousins. One starless galaxy means there could be more. Scientists are planning to scour the skies with radio and infrared tech, hunting for other ghostly galaxies that might be hiding in plain sight. Unlocking the past. If J0613+52 is a primordial relic, its gas holds clues to how galaxies first formed. By analyzing its composition, we could figure out why some gas clouds ignite into stars while others stay dormant. It's like piecing together the universe's baby book. Tech boost. Tools like the James Webb Space Telescope could zoom in for a closer look, double-checking for any faint starlight or confirming its starless status. Every new observation sharpens the picture. The road ahead is thrilling. J0613+52 could spark a wave of discoveries about the early universe, dark matter, and beyond. Why it hits home. Let's take a step back. Why does a starless blob 270 million light-years away matter to you? Because it's a wake-up call that the universe is still full of mysteries. Every time we think we've got the cosmos figured out, something like J0613+52 comes along to keep us guessing. It's humbling, exciting, and a nudge to stay curious. Plus, it's a story of serendipity, a typo turned into a breakthrough. That's the magic of science. One small slip can open a door to the infinite. As we close out this documentary, let's soak in the wonder of J0613+52. It's a galactic riddle, a time machine, and a call to keep exploring. The universe is vast and weird, and we're lucky to be along for the ride. Thanks for joining us on this adventure with Galaxy Guru. If J0613+52 has lit a spark in you, don't let it fade. Keep asking questions, keep looking up. The cosmos has endless tales to tell. That's a wrap for now. Loved this journey? Hit subscribe for more cosmic stories. Until next time, stay curious, and we'll catch you on the next orbit with Galaxy Guru.